Assalamualaikum warahmatullahi wabarakatuh and hello everybody. Our group consists of 5 people for this assignment, SCL assignment for advanced calculus, which is Nurul Atika binti Muhammad Razi, Nurul Hasanah binti Muhammad Razi, Muhammad Zakwan bin Yusuf, Aisyah Nazirah binti Muhammad Saleh, and finally Ahmad Kabir bin Nashal Ali. Now you can see the video for the solution for the questions from every member from this group. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Atika binti Muhammad Razi and my metric number is 202824. Today, I am going to explain for the first question of SCL. It states that use Green's theorem to verify that the line integral over a closed loop, which denoted as C, of y squared x plus x squared dx plus 4x minus 1 dy equals to 99 over 4, where C is formed by vertices of 0, 0, 0, 3 and negative 3, 0 oriented counterclockwise. Generally, Green's theorem explains, let C be a positively oriented or counterclockwise direction, piecewise smooth, simple closed curve in the plane, and let R be the region bounded by C. If P and Q has continuous partial derivatives on an open region that contains R, then the line integral over a closed loop of P dx plus Q dy equals to double integral over a region of partial derivative of Q respect to x minus partial derivative of P respect to y dA. Before that, we need to illustrate the region from question given, and it will be like this. First step is, we need to determine the maximum and minimum of x points. I will denote A as minimum point and B as the maximum point. For A is equals to negative 3 and B is equals to 0. Second step, for y limit, we need to use the linear equation. From the diagram, we can see that there are two equations of y. First is y equals to 0 and the second one is y equals to x plus 3, which is formed from general equation of linear equation ymx plus c. For the third step, we need to determine the partial derivative of q respect to x and the partial derivative of p respect to y from the line integral over a closed loop of pxy dx plus qxy dy. We can assume that p of xy is equals to y squared x plus x squared, and for the q of xy is 4x minus 1. We can get from the question here. For the partial derivative, each of them we can get 2xy and 4. For the fourth step, we need to plug in into Green's theorem formula. The values from step 1 until step 3, we substitute into this general formula of Green's theorem. And it will be like this. First, we need to integrate the limit of y, like this. And then, we need to integrate the limit of x, like this. And then, we solve it. We obtain 99 over 4, which we have verified the question here.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Hasanah binti Muhammad Razi and my metric number is 200294. So today I'm going to explain SL question number 2 and evaluate line integral along C y x squared dx minus y squared x dy, where C is x squared plus y squared equal to 2 square oriented counterclockwise. As we know this equation, x squared plus y square equal to 2 square is a circle equation. So we draw the circle like this. First, we notice that this is a circle and it is closed, so there is no holes in the region R. Also, we will use the convention here that the circle has a positive orientation since the question state counterclockwise direction, and then the region R always be on the left. We could evaluate this integral by using Green's theorem because our region satisfies the requirement of this theorem and it makes the calculation much more simple. And based on this Green theorem equation, which is line integral along C p dx plus q dy equal to double integral over the domain R of dq over dx minus dp over dy dx dy. We need to find P and Q, so we let Pxy and Qxy and we get Pxy equal to yx square, Qxy equal to negative y square x. And then we solve the partial derivatives and we get dp per dy equal to x square and dq per dx equal to negative y square. After we got the components of vector fields and the partial derivatives, we fill out the Green's theorem equation and we get line integral along C yx square dx minus y square x dy equal to double integral over the domain R of negative y square minus x square dx dy. Then we bring out the negative sign outside the double integral and we get negative double integral over the domain R of x square plus y square dx dy. Since 2 is the radius of the circle that centered at the origin, we can transform it into polar coordinates like this, and we obtain double integral over this region. And we need to simplify this form as we know that the trigonometric identities cos square theta plus sine 2 theta we get 1, and then we simplify this, we get r cubed dr. After that, we integrate this equation, we get negative 2 pi dot r power of 4 over 4 evaluated from 0 to 2. We solve this form, we get negative 16 pi over 2. We simplify this, final answer is negative 8 pi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakwan bin Yusuf. My metric number is 204246. Today I will present about SCL question number 3. So this is the equation. Show that this function equal to 3 using Green theorem where C is formed by vertices 0, 0, 1, 0 and 1, 3 oriented clockwise. First of all, I draw the area that we want to calculate. So this is the first vertices, which is 0, 0, and here is 1, 0, and here is 1, 3. So when we combine the line between of these three, we got this area, and for sure this is the area that we want to calculate. So the function of this line is y equals to 3x. So when the question mentioned that oriented clockwise, I draw the arrow which is clockwise, the arrow. So before to start the calculation, I determine which one is x and which one is p and which one is q. So this is p and this is q, like what I write here. P is set of 1 plus x cubed and Q is 2xy. So to start the calculation, we use this formula, which is double integrate for dq dx minus dp dy dA. So since we already know what function p and what function q, so it's easier to differentiate to solve this formula. So let's continue. So we need to differentiate the function of q respect to x. So when we differentiate this function, we got 2y, like what I wrote here, and when minus with differentiate of function p respect to y, so there is no y here, so it will become to 0, so I didn't write here. So the answer for this equation is only 2y dA. So let's continue. So I write here 2y dy dx. So since I write dy first, so this need to be y limit of y, which is from 0 until 3x, and this limit for x from 0 until 1. So I need to integrate respect to y first. So when I integrate 2y respect to y, it will become 2 square, and we need to substitute with 3x minus 0. So when I substitute it, we will got 9x square. So this function we need to integrate respect to x with limit 0 from 0 until 1. Then if we integrate this function respect to x, we will got 3x cubed, and we will substitute it 1 and 0. So when we substitute it, we got 3. So it's shown like what the question needed. So that's all from me. Thank you.
For question number 4, the question is curve is shown below. Evaluate this equation. So for this question, we need to use double integral, and for solving double integral, we need to use this formula. Okay, so first, whatever in front of dy is x function, and whatever is in front dx is p function. Make sure you include the sign there, p and q. So to solve this using the double integral, we take the partial of q with respect to x in this equation. So we got -9 minus the partial of p with respect to y from this equation. So we got -x respect to dy dx. Okay. Then to solve the double integral of this equation, first we need to find the range, the x and y range. For y range, the below part, we got this simply gonna be the this simply gonna be the y equal the range y equal to -1. So y equal to -1 for the below part, and the upper part, the top part, we need to find the y using the formula y minus y1 using the formula mx negative x1. First we need to find the m first, m. So using this point and this point, okay, this point and second point. So the m is using the formula y2 minus y1 divided by x2 minus x1. Okay, so y2 is 2 minus 4 divided by x2 is 1 minus -1, and then we got -1 for the m. Okay, next we find y, -y1 for m, x minus x1. So using this point, so y1 is 2 and the m is -1, x minus with x1 is 1, and then we got negative x plus 3. Okay, so the top part will be y equal to negative x plus 3. Okay, respect to dy, and then for the range of x, the x value, just range it using this x -1, x -1, x -1, and x -1, x +1 and x -1. Okay, so now we use the Green theorem to calculate. Okay, first you're gonna integrate -9 plus x I'm gonna integrate, so -9y plus xy, plug in the upper limit and the lower limit, y negative x plus 3, y equal to -1 with respect to tx, and then we just solve this. So -9 y negative x plus 3 plus x times negative x plus 3, and then negative 9 -1 include substitute here y equal to -1 in this, and plus x -1 dx. So next, we have to integrate respect to x. We solve this equation and we got 9x -27 negative x square plus 3x minus 9 to x, 9 minus x dx. Okay, we integrate respect to x and then we got just solve this first to make it easier for you to solve. Okay, this time we really need to integrate with respect to x. So integrate first 13x squared over 2 minus 36x minus x cubed over 3. The range is x equal to 1 and x equal to -1. Okay, so 13 over 2 minus 36 minus 1 over 3 minus 13 over 2 plus 36 plus 1 over 3. Okay, equals to negative 179 over 6 minus 257 over 6. For this, then just solve this. We got 2 negative 218 over 8. And this is the final answer. That's all for me. Thank you.
Okay, this is the question 5 for SCL. Use the Green's theorem to verify that area of the disk is of a radius a is a square pi. Okay, the normal Green's theorem is the formula for the normal Green's theorem is actually this. Integrate a closed region with C, p dx plus q dy, and from here it will become like this. Double integral of a region over a region, partial derivative of q to x minus partial derivative of p to y dA. And as we all know from this question, they didn't say anything about the formula for the region, right? So we just use double integral over a region 1 dA. We just use 1 because they didn't say anything. So we want to cut this formula into, we want to make this formula into this actually, but it's really hard to cut 1 into 2. Like we really want to cut 1 into the partial derivative of q per x over x and partial derivative of p to y. So I think it will be much more easier if we make 1 into 2. So we just make 1/2 double integral over a region 2 dA. Actually, if we just cut it, it will become this question. It's just the same, but we just make it 2 for us to easier to what we call split into 2 like this. So how can we get 2 from this formula? So what minus what we get 2? So it is 1 minus -1. So we just make it like this, and this is actually from the formula of here negative y dx plus x dy. This is how it is done. Actually, this is just the reverse version of the green theorem that we always do. So this is just the info, because we just want to take this like half double or integral over a region 2 dA only. We just want to take this formula and straight away do this equation. But I just want to give you the idea about how we got 2 actually. Okay, So, okay, from here, okay, from the question, they didn't say anything, but they said that the region is a disk and they have a radius of A. So disk is actually circle and radius is A. So actually, we want to use polar coordinate for this because this is a circle. So when we see a circle, we straight away think that we need to use polar coordinate formula. So the thing that we must make sure we have is radius and also theta. So we need to make a region for radius and theta. So the radius, we know that the radius is A. So the region is from 0 to A. And for theta, it is actually a complete circle, right? So the theta is from 0 to 2 theta because it travels a whole circle. And as we know, the Green's theorem is actually counterclockwise. So it travels like this. Okay. So yeah. All right. So now let's move on to calculating this. So from this formula, which is half double integral over a region 2dA, we make it into polar coordinate formula, which is just we make sure half is there and just write double integral 2 and remember to write r dr d theta because we are using double integral, so we need to write r dr d theta here first. So from there we see, okay, which one is coming first? dr, right? So the what we call the region for r will be beside number 2 and then we do theta. So don't forget to write r and theta like this because we can avoid doing some silly mistakes here. So r is the region from 0 to a and the theta is from 0 to 2 pi. Just write it like this. It can help you a lot in your exam later. Okay, so let's integrate into r first. 2r integrate into r, we got 2r square over 2. Just cut 2, we have r square. So we need to substitute r into a and 0. So we get a square minus 0 square, which is a square. So now we want to integrate into theta. So we get a squared theta. So the theta is from 2 pi and 0. So we need to substitute 2 pi and 0 into the formula. And we got a is 2a square pi minus 0. So half times 2 is actually 1. So we can just cut it. So we get a square pi. A square pi. Yeah, this is pi. I'm sorry if I mispronounced it before. This is pi. A square pi. So the answer here is a square pi. So they asked us to verify that the answer is a square pi, right? And this is what we got. So it is verified. That is all for me. Thank you.